Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you're doing well. So, in our last lecture, we learned about equilibrium constant and its expression unit and how it will helps and us to understand the state of equilibrium. Radio student, today's lecture is very important and very interesting. Also, very important for your both exam levels and real life applications, which is importance or applications of equilibrium constant. So let's begin. The first applications or importance of equilibrium constant is prediction of the direction of chemical reaction. When you're studying the equilibrium constant helps us to predict which sides, when forward or backward, a reaction will proceed to attain equilibrium. But you're studying if case is very large, the reaction proceeds mostly in the forward direction and products are favored. If case is very small, the reaction proceed mostly in the reverse direction and reactants are favored. Example, N2 is a gas plus 3 2, which is also a gas, gap 2 it is 3, which is also a gas. For this reaction, the equilibrium constant K is large at lower temperatures, meaning the forward reaction mean formation of NH3 is favored. And second applications or second importance of chemical equilibrium is indication of the extent of reaction. When you student, the value of Kc also tells us how far a reaction goes before equilibrium is established. Large Kc mean greater than 10 power 3. Reaction proceed almost completely to form products. Intermediate Kc means 10 power minus 3 to 10 power 3. Significant amounts of both reactants and products are present. Small Kc mean less than 10 power minus 3. Reaction hardly proceeds, reactants dominates. Example for the reaction, H2 is a gas plus I2 is also gas, F2HI is also gas. Kc is approximately 49 at 500 Kelvin. This show both reactants and products are present and measurable amounts at equilibrium. And third one, applications is calculation of unknown concentration at equilibrium. When you're student, if you know the value of Kc and the concentration of some species, we can calculate the unknown concentrations of others at equilibrium. Example, for N2 is a gas plus 3H2 is also gas, Gaf2NH3 is also gas. If you know concentration of N2 and concentration of H2 at equilibrium and Kc, we can find concentration of NH3. This is very helpful in numerical problems and laboratory work. Now, fourth one applications or importance is helps in the study of industrial processes. Dear student, equilibrium constant play a key role in industrial chemistry and optimizing conditions for maximum yield. Let's see two famous examples. First one, Haber process in manufacture of ammonia. N2 is a gas plus 3H2 is also gas, Gaf2NH3 is also gas. The equilibrium constant helps determine the best pressure and temperature to get maximum ammonia yield. For maximum yield, high pressure favors fewer gas molecules. Low temperature favors exothermic reaction. And the second process is contact process we manufacture of sulfuric acid. 2 is a gas plus O2 is also gas, Gaf2SO3 is also gas. Here again, equilibrium constant tells us the conditions to maximize SO3 formation, moderate temperature, and high pressure. So Kc helps industries save cost, increase yield, and reduce waste. And fifth one is prediction of feasibility of reaction. By comparing the reaction quotient with the equilibrium constant Kc, we can predict whether a reaction will go forward or backward to reach equilibrium. If Kc le- less than F, Qc is less than Kc, reaction moves forward mean to form products. F reaction quotient mean Qc greater than Kc, reaction moves backward means to form reactants. F Qc is equal to Kc, system is already at equilibrium. Example, in H2 plus I2 gave 2Hi. If initially Hi is low, Qc is less than Kc, mean reaction proceed forward until equilibrium is achieved. Now, sixth application is useful in the study of biological and environmental system. In biological systems like blood, buffering, and in environmental system such as dissolved gases and ocean, equilibrium constants helps scientists understand the balance between reactants and products. For example, in blood, carbonic acid H2CO3 is in equilibrium with CO2 and H2O. CO2 plus H2O give H2CO3. This equilibrium maintains the pH of blood, showing how Kc is important in living systems too. So, my dear student, this is all about today's lecture on importance or applications of equilibrium constant. I hope you understand. So if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lecture, and share it with your friends. Comments your question below. Take care and see you in the next class, inshallah. Thank you for listening.